This is a video for the chi-square test for one-way designs. That means when you have only one variable. Here, a principal wants to know if the teachers think their teacher performance evaluations are fair. There is 3 methods, and out of 180 teachers, 63 rated method 1, 45 rated method 2, and 72 rated method 3 as fair. Notice that each teacher is only in one group. They only rate one method as fair. Now at the 5% level of significance, is there a difference in perceptions between what we expect and what we observe? Right? So we always get the observed information, and then we have to figure out what we would have expected ourselves. So here, if each level has an equal probability, we take the 1 and divide it by the number of levels. So here we have 3 different methods. So 1 divided by 3, or 1/3, is 33.33. Or we expect for 33% of the teachers to be in each group. Now, if you want to know the exact frequency or the exact count, you can divide the total number of people by the number of levels. So number of people divided by number of levels. Or the sample, it's a better way to say it, n divided by number of levels. Now, for the calculation, I really recommend to follow this process right here, because it's exactly the same thing for the test of independence when you have 2 variables in your chi-square. It's the exact same thing. So first you set up a table with 7 columns. So I'm going to go over to Excel and set that up. Actually, I have it up here. That's what we're going to try to get to, but I'm going to do it from scratch. So I'm going to create 7 categories. I could go 1, 2, then you can drag this over. So 7 categories. And I'm going to copy these titles, because if you don't have them, you can write them, or you can copy them from the file that you have. So the first step is set up a table cell columns and then list each category in column 1. So column 1 are the categories. So we have method 1, then method 2, method 3. So these 3. And then we can also write it down here at total. Then list the observed frequencies in column 2. So what are the observed ones? They're 63 method for method 1, 45 for method 2, and 72 for method 3. So I got that from here, from those instructions. And now we basically have all the information that we need from over here. Right? The next step is list the theoretically expected proportion in column 3. So column 3, expected proportions is equals, that's the, every time you hit an equal sign in Excel, that's to calculate the formula. So it's 1 divided by 3. That's the expected proportion, and that's 0.33. Right? And if you add up, if you sum these up, so again we hit equal and we want to calculate the sum, and the sum of this area here, we use this as the formula. So that added these up. I could have also typed this equal this cell plus this cell plus this cell. Same thing. And then we drag this over here. And you know that all the proportions together have to add up to be 1. Then for expected frequency, we multiply the proportion with the total amount of people, or total amount of people times the proportion, right? if you have a total of 180 people and in each category you want the equal amount, you can divide 180 by the number of categories, which here it's quite straightforward. It's 60. Sometimes it's a little bit more complicated, and then we can do the same thing, and we have to just adjust this formula because it tends to we have to make sure we have the right things here. Okay, so we have the expected frequency and the observed frequency. Now we can calculate our difference. So it's the 63 minus 60 is 3. I'm going to again make it a formula. 63 minus 60 it takes a little while, is 3. And now what we can do is choose this field and drag it down. So here we have 45 minus 60 is 15, 72 minus 60 is 12. So here we have 3 people more than we expected. For method 2 we have 15 people less than we expected, and for method 3 we had 12 people more than we expected. So now we square the difference, right? So we have no negatives, and the bigger differences are exaggerated a bit more, right? 3 becomes just a 9, and 15 becomes 225. And then we set the difference in relationship to the expected value, right? And these are then our components for the sum. If we add up these components, we get our chi-square, which is 6.3. This here added up, this plus this plus this is 6.3. This is our chi-square, and you can repeat this process for you know, if you have 12 categories, it's 12 categories, or if you have another component, for example, if you have a, let me just go over here, if we have a test of independence where we have 2 variables, then what we can do is look at these cells and look at them as cell A, cell B, cell C, cell D. And then you can have categories for each one of them. So you know what did we observe in each cell and what did we expect. So this here will look exactly the same. This calculation will look exactly the same.